Okay guys, we're going to do number 2 from Elecricity 6. I'm doing this in the middle of the night because I'm going to be sick today, so please give me some leeway here. Okay, so the first thing to do is to color code our circuit. So all of this is the same voltage. All of this is the same voltage, but a different one. Let's see, how about orange? Let's see, this is the same voltage, and that is the same voltage right there. So right now there's nothing that is parallel, but I do have some stuff that is in a series. For example, this 2 and this 4 are in a series. Because they are in a series, we can just add them so that it becomes 6. Now, this 6 and this 12 are in parallel, because the 6 goes from green to pink, and the 12 goes from green to pink. So we're going to do that one next. Let's do the 6 and the 12. So I have to do that fraction thing. The equivalent resistance will be 1 over 6 plus 1 over 12. Those are fractions. I have to add them, which means I need a common denominator. So I'm going to do 12. To turn this 1 6 into 12, I multiply top and bottom by 2. I get 2 12ths. Now I have 2 12ths plus 1 12th, which is 3 12ths. And then to actually get the answer, I have to flip that over. 12 over 3, which equals 4 ohms. Okay, so altogether this top bit here is 4 ohms. Now, that whole thing on top is in series with the 5. So we're just going to add them to get our final answer, which is 9 ohms. All right, next up, we need to find the total current. The total current is equal to the total voltage divided by the total resistance. The total voltage is the battery, and we just found the total resistance. So our total current is 6 amps. That means that the current near the battery is 6 amps. So, like right here before it splits up in that, junction, 6, not 9. 6. And then again when it comes back to the battery. Now I don't know how that 6 is going to split up. It's not going to be even because the top branch has a total of 6 ohms of resistance and the bottom is 12. But I do know how much goes through this 5 here, because that's 6 amps. It must have traveled all along the bottom here. In fact, ever since this junction back here. So there must be 6 amps going through that 5 ohm resistor. I'm going to start there. Then, since the voltage is current times resistance, the current is 6, the resistance is 5, so the voltage across the 5 ohm resistor must be 30 volts. I'm actually going to use that to decide how the current broke up here, because I can find a path. Let's see, let's do... There we go, let's try green. If I follow this path here, along here, down, through here, and back, I know that when I travel that path, I need a total voltage drop of 54 volts. I already have 30 volts from this 5 ohm resistor right here. That's got to be 30 volts. So if that's 30, and there's only one other resistor in this path, the other resistor must take up the rest of the volts, which means it must be 12. So the 24. 50 minus 30 equals 24. So the 12 ohm resistor must have 24 volts. Therefore, since current is voltage over resistance, the current going through the 12 ohm resistor must be 24 divided by 12, or 2. Oops. Oh, I closed it. No. Okay, I'm back. Okay, so the current going through the 12 ohm resistor must be 2 amps. So of that 6, 2 must have gone this way. which means 4 went the other way. So that means 4 is traveling through the 2 ohm resistor and 4 amps are traveling through the 4 ohm resistor. So I can fill those in. 4, 4. And then I can find the voltage with Ohm's law. 2 times 4 is 8. 4 times 4 is 16. Notice if I took the dot path, I also would have had a total of 54 volts. Because when I cross the 2, I use 8. When I cross the 4, I use 16. That there. Sorry, my voice is dying. It's 24. And then I keep going. And there's another 30. And that's a total of 54. Okay. I'm not going to do the power. You can do the power yourself. It's simply I times V. So I hope this helps. And I should be back tomorrow.